And shoot, I thought for sure I opened a PowerPoint. It's interesting. Okay, this is section 7.1. And I guess I'll open up the book. Like questions, so if you have questions as we're going through this, be sure to ask. I'll never make you feel bad for any question you ever ask. Yeah, there are no stupid questions. You're trying to understand the material. I take that back. Somebody asked me a question earlier this week. I thought was just as stupid as could be. I didn't say it to them, and I assumed that they had were using their phone to send a message and it autocorrected. I'm sitting here, it's just like, what in the world is she talking about? This doesn't. So the only thing I could think of is autocorrect. Either that or she was high when she sent it. One of the two.
Well, let's try to pirate this book off the internet. What's it called? Calculus by 11th edition. 11th edition.
Yeah, I don't think it has any other name. You know, there's early transcendentals in some. There's all kinds, but I think this one's just calculus. Yeah. Now, section 7.1, area of region between two curves. The concept of it is you're trying to find this area right here. So very simple. You got in this kind of setup, you got where they intersect, so points of intersection. You got a graph that's on top, and you got a graph that's on the bottom. Or if we're looking at it from right to left, we look at it differently. I'm not big on theory, so if you took this class to really dive into the theory, I'm more about showing you lots of examples. So I love examples. I guarantee I could not present this theory any better than the wording they have written right here. So if you read that, then you'll get a lot better coverage of the theory I could even dream of doing. Okay, now this is in sense what our formula is, where we got the integral from a to b, and that's going to be in x's, and then your graph above minus your graph below. Now, before we get into that, we're going to review some of this, just in case you've forgotten it all from Calc 1, or maybe you've never even seen it or something. So we're going to review points of intersection. Okay, so we got y equals x squared minus 2x, and y equal to 7x minus 8. Now, since they're both equal to y, I can set the right sides equal to each other. So I got x squared minus 2x is equal to 7x minus 8. This is a quadratic, so we want to get everything over one side. So I'll take the 7x, move it over, becomes a negative 7x. Take the negative 8 over, becomes a positive 8, equals 0. Combine like terms, negative 2x, negative 7x is negative 9x. This will factor, so this factors as x minus 1 times x minus 8. The zero factor property, zero product principle, whatever you learned it, the name of it, where you got this side factor and equal to 0, you now set each one of these equal to 0 and solve it. And you get x equals 1 and x equals 8. Now this would be enough if we were setting up a problem in terms of x's. But let's go and get the y's also. Now, it doesn't matter which one you plug it in, but really the one with that looks easier is the one you should pick. This one doesn't have a squared, so I'm plug it into the y equals 7x minus 8. And we've got 7 times 1 minus 8. 7 minus 8 is negative 1, so this point is 1, negative 1. By the way, I'll never get upset if you see a mistake I make. Point that out. What's that, 56 minus 8, or 48? So that'll be 8, 48. Kind of dragging a little bit today. My dog had a seizure in the middle of the night last night. So I had to get up at 2 o'clock and hold her while she went through that, or well, not while she went through the seizure, while she recovered. She was done with the seizure by the time I flew out of bed. Questions on that? Nothing. It's my baby. I couldn't just leave her. So I stay out there until she can get up and walk by herself. So. She's the only one that looks happy when I come home at night. Well, that and the other dog, too. No wonder you teach Calc 2 at night. Okay, graphing calculator. Assume everybody's been on Desmos? Okay. This is why they don't require you to have a TA3, TA4. If you look on the book list, it says optional. Is because you can use this. And things I put on the test don't really require graphing, or if they do, they're very simple graphs, like lines or very basic quadratics. You know, you should be able to graph y is equal to x squared minus 3. So now, if you haven't seen this, I'm going to show it. This is especially handy to see what's above and below. So y is equal to x squared minus 2x. Do a down arrow. And then y is equal to 7x minus 8. Now, intersection says 1, negative 1. What did I type in wrong? Oh, there's 1, negative 1. Never mind. If I put my cursor on that and click, you see it says 1, negative 1. I can't see the rest, but you can do the wrench, and you can change your settings here. So if you want your y to go up to 50, you can put that in here. And then you can put your mouse over that. So it's pretty easy to verify if you got the right points of intersection. You just come out here and click that. And you can also see which one's above and which one's below. Obviously, the blue is above, isn't it? That's going to be important in our setup. Blue, of course, is the line. Okay, evaluate indefinite integral. You should remember how to do that. So I'm going to review that. Sometimes you can tell with the concavity. Otherwise, you could plug in a test point. Those are probably the two ways I know. Like I was refreshing my memory earlier today just so I didn't come to class and I forgot everything since last semester. And there was one problem that had like a positive x squared and one had a negative x squared. And I knew since they're finding the area in between it, and one's curved up like that and the other one's curved down, I knew which one was above right away. Okay, so 1 to 3. x squared dx. So the integral of x squared is, yeah, 1/3 x cubed. You add 1 to your power, divide by your new power. You know, I couldn't think, well, I don't know when I got married, actually. It's in September. Been 21 years. So, but my memory's not so good. That's why I assume your memory maybe is not so good either. So maybe you forgot. So that's why I do a lot of reviewing. So it's boring to some people, but other people need it. So then you could bring this 1/3 out in front if you wanted to. And we plug the top number in for the x. So I'm going to have 3 to the third minus, and you plug the 1 in, minus 1 to the third. 3 to the third is 27, minus 1 gives me 26. So that gives me 26 thirds. If I start going too fast, then holler. In case you're wondering, I do give you the entire class period for the test. Even if it means I'll record something in YouTube video format for a section, you have to watch it at home. Students seem to prefer to have that time so they could just do the entire test and not be rushed trying to do it in an hour and 20 minutes. Let's see.
What's the frequency?
No, it's let's see, we have the 7, 8, 9, 10. Yeah, something like that. Okay, now if I go to the y equals on a TA3, TA4, press clear, and put in the x squared. Now to do this with the calculator, where do you go? Second trace, and you choose number 7. Now you can down arrow to it and press enter, or press the number 7. It'll come up with a graph there, and it asks you for the lower limit. That'd be 1. Enter. Then it'll ask you for the upper limit, which would be 3, and you press enter. And it comes back and gives us 8.666 and so forth. Has some of you ever seen that before? That's quite important because we're going to be doing some problems that would be horrible to do completely by hand. And so I may have you do a few just to get it, but then we'll quickly switch over to doing the real hard ones like this. And some of them you can't even find the integral. And there's a numerical method. I think you cover that in Calc 1. I don't remember. But there's a numerical method for doing it. And there's also using a calculator like this. Desmos doesn't do this, though. There is a way to change this to 26 thirds. I discovered it one time, but I don't remember now. It's been too long. I think it's under bars somewhere. Even and odd functions and integrals. So x squared from -2 to 2. So for 10, this is x squared. Boy, that's bad. Could be worse. Is that a even or odd function? Even. Because it's symmetric to the y-axis. So I can rewrite this how? from 0 to 2, which would be the right side here, right? And then put a 2 out in front. So you can use symmetry to work these. Now that becomes important when we get to polar. Not that I can draw these. But if you have this, and sometimes when you try to go from 0 to 2 pi, it just doesn't work out well. So instead, we go from 0, and what is this right here? Pi over 2. And we're finding just this one leaf right here in terms of integration. And then multiply by what? 4. It isn't usually as easy as that because these usually have a pattern like as it's tracing it here, it goes down like this. And so 0 to pi over 2 is not actually this one here. But I was just doing that for demonstration's sake. But yeah, we'll use that concept to help us do it. And then you'd find us this direct integration here. Okay, use substitution. We'll do a lot of use substitution. Yeah, this is a fun class. I like Calc 2. A lot of people hate it. Yeah, that's what people say.
You agree?
No, I don't agree at all.
What's the worst one?
Well, I don't know. I've gotten used to Calc 3, so I don't know. Calc 3 was the worst for me. That was back in the dark ages. And if you think two-dimensionally or one-dimensionally, it's hard to do calculus in 3 dimensions. Like I'd try to draw a picture of a saddle so I can understand saddle points, part of Calc 3. And if you see me draw a saddle, maybe I might not be too bad at all. Well, I'm drawing in 2 dimensions. Potato chips, yeah. Frito. Here's a high point of the Frito. If you can't draw a saddle, then you can't really envision what you're going to do. And that put me at a big disadvantage in Calc 3. Now that I've taught it last 2 or 3 summers, now that I teach it, I use those tools to give you the picture, and they're fantastic. You can exactly see what you're finding. You understand the saddle points and all that. Okay. What would my u be here? Yeah. So x squared minus 3. And derivative of that is, and then dx. Remember, we got to count for everything. So here's a dx, here's a dx. Here's an x, here's an x. The thing that's missing is the 2, so that's easy. We can put a 2 in there. Now, this would match. This would match, and that would match. How do I offset the 2? Yeah, half out in front. So now we can do our substitution. The 2x dx gets replaced by du. This x squared minus 3 gets replaced by u. So I got e to the u du. The integral of e to the u is e to the u plus c. And then we plug our u back in. U we said was x squared minus 3. So we got 1/2 e to the x squared minus 3 plus c. There's a one of the sections out of this chapter does a lot of reviewing for these techniques. So if you've forgotten use substitution, you'll be reminded of it. So.
Yeah, that right there.
You don't remember that? Oh, and I allow notes on all my tests, so not open notes, but certain number of pages, yeah. And examples, whatever you want to put on. I guess probably 3 pages sounds good. So whatever you want to put 3 pages front and back. So I don't have a good memory. One of the problems I'm going to show you tonight, if we get that far, is involving the integral or derivative of cotangent. For like me, I don't remember what it is, so I'll have to cheat and look it up unless somebody remembers. I could rewrite cotangent as cosine over sine. I could yeah. So if I can't remember it, I'm not going to sit there and expect you to remember every formula. So. Let's see. Let's look up values on unit circles. Sine of pi over 4. And of course, you can have the unit circle if you've never seen a unit circle, you definitely want to have it on test. But what is that point? Sine. Right. How about this one? This is pi over 6. Uh-huh. How about this one? Well, you guys are good. Look at that. And of course, this is pi over 3. These are easy here. But, and then of course, if you know those, you know all the rest of these. The only thing that changes is the sign. So by symmetry. So what's sine pi over 4? Yeah. So square root 2 over 2. Because sine is what? The x or y? Y. Exactly. How about what's cosine? X. Sine, of course, we just said was y. Tangent is y over x. Cotangent is this for y. Secant is 1 over x. 1 over y. You guys have it. Some people never took trig. They went straight into calc 1. Does anybody not take trig in here? One person? Okay. Oh. Now, if some of these topics are kind of alien, you need a little bit of refresher. Besides the few minutes I'm just spending on each topic, there's a website, mathheals.com. Math Heals. So there's math lectures here. It heals. It's healing powers. And here's trig. And there's YouTube videos covering all the different topics. So if you don't know what a unit circle is, go watch this YouTube video. If you have trouble sleeping, go watch that YouTube video. It's beneficial in many different ways. Now, here's Calc 1. So if you've forgotten a lot from Calc 1, I have YouTube videos out there for every topic. Don't click the WebEx video. I need to remove those. Those back. Yeah, I created all these. The what? This is my website. Yeah. And yeah, watch a YouTube video. Don't watch WebEx. The one that's not out there is Calc 2. Says coming soon. It's been saying coming soon for 16 years. So I'm guessing it's not coming soon. I think there's links here, but they point to nothing. They point back to that same page. It could. It has healing powers. I guarantee it.
That's the first time I've ever heard that from anybody.
Well, I had headaches that wouldn't go away. pounding migraines. Doesn't matter what I took, never went away. Went to the doctor. They did the little scans. They were checking to see if I had some kind of tumor or something. And why they would do this, I don't know, because I'm clever with computers. But they gave me the little CD or DVD or whatever they burnt, and they said, "Here, give this to your family doctor." I don't know why I was a courier for it. Of course, me, I take it home, I immediately put it in my computer, and I find me a viewer for it and see pictures of my brain. And I see the one with the big white spot on there, and I'm looking there. I'm done. I'm planning my end, and it's just like, this looks obviously it's inoperable. I had all diagnosed, and because I went on Google and I found a picture of a brain tumor, and it looked exactly like that. And then I went to the doctor. Turns out my pituitary gland screwed up. That's why I had bad headaches. Nothing to do with the tumor. And anyway, the point behind that is the only time that my head would quit pounding is when I was teaching math. That's the only time. Other than that, it didn't matter day, night. It was just constant. So, Matthews.
What a story. I know. Maybe I don't think.
Now, I know some of you computer science people got to know it, right? Oh, you're kidding. The computer science people don't know what that is? There's a product called Blender. It's an animation package. That's Ludwig. So yeah, he's the kind of the famous person for Blender that a lot of people use for modeling. So yeah, he's interesting. Okay, let's see. That was okay. This one, number 6. You should know how to solve trig equations. Sine x is equal to 1/2. What is it? What is the answer? Does anybody know? Or between 0 and 2 pi. Sorry.
So sine x equal to half.
Yeah.
That would be
I heard of pi over 3. 11 pi over 6. What's this point right here? Pi over 6, yeah. Yeah, because this is square root of 3 over 2 and 1/2. We're looking where sine is equal to 1/2, which is right here. So pi over 6, that's wrong. What other quadrant is sine equal to 1/2 at? Yeah, 5 pi over 6. Yeah, because this is also square root of 3 over 2 and 1/2. So yeah, those would be your answers. Again, I got a video out there in that site for trig equations if you've never even seen a trig equation. So. Not that I won't answer your question if I work a problem like that in this class. Say, well, how do you get that? No, I'll cover it.
Are trig identities the same?
They use many of the same properties, identities. Because a lot of times when you're solving a trig equation, you have to use those properties to rewrite it. And when you're doing identity, you have to use those properties. Okay, last recall is the integral of 1 over x or 1 over u. What is that equal to? Yeah. And what else? Plus c. That took 2 points off on every problem on a final in Calc 1 time because they didn't put the plus c. Says, I can't believe you took points off on every one. Well, you missed every one of them. So I do get partial credit. Each one's worth 10 points, so the person didn't miss all of it.
What is perceiving the absolute value of that?
Oh yeah, natural log, ln.
I usually see that in lowercase.
I always write mine wrong. Teach college algebra every semester since the beginning of time, seems like. Yeah, it'd be a 3-hour class I'd be teaching. I'd say log this, log this. We use the definition of log, properties of log, but log over and over as I write down log 300 or 400 times. Never failed. Somebody at the end of class would come up and ask what this 10G was. I kept writing on the board. I knew my mind would snap at some point. And that is truly a stupid question. I mean, there's no doubt about that. It's just like, yeah, I mean, you didn't make a connection to 300 or 400 times. I said log as I wrote down 10G, and so I deliberately write my logs incorrect. So nobody seriously asked me what 10G is. I keep writing on the board. 10G. I think that means you're going to be taking the class again. Okay. Now these problems are going to ask us to do the setup. And I already talked about this where you do subtraction. One on top minus one on the bottom. And we'll see when we go right and left how to handle that too. So a lot of these you can probably eyeball and see. And I'll put these PowerPoints up there. So if you don't get all written down, don't stress. Actually, I think they're already up in Canvas. Okay. So what would it go from? What value to what value? Is it 5? But my eyes aren't very good. 5-ish. How would I actually find out true value? Yeah, points of intersection. So if I did x squared minus 5x plus 4, and I set it equal to 2x minus 2, and then take the 2x over becomes a negative 2x, take the negative 2 over becomes a positive 2. So we got x squared minus 7x plus 6. Factors as x minus 1 times x minus 6. Zero factor property. Set each factor equal to 0. And 1 and 6. Not 5-ish. 6-ish. Some of them you'll be able to see. And I could also, instead of doing this, I could put it in a Desmos. Desmos would allow me to see that. Of course, that wouldn't help you on the first test because you can't use cell phones on a test or your laptops because obviously Mathway and Photo, what's that one on the iPhone? Oh, does it? Yeah. It's no more free. Well, this is the line, and it's obviously above the other one, isn't it? Our linear is the 2x minus 2 minus the one that's below, which would be this part right here, which is the x squared minus 5x plus 4. And then dx. All they're wanting here is a setup. They're not wanting us to actually find it. And I don't have any problem with you using a T89, TI91, whatever it is. But you do have to show your work. If you don't show your work, you don't get credit. Even if you get the right answer. Yeah. Because if anybody got a T89? Nobody? It does everything from Calc 1. It does a lot of Calc 2 also. Yeah. So let's take a look at number 2. This one I probably don't need to find the points of intersection. If something worthwhile doing, like I was designing something, of course I would want to make sure it's negative 2 and 2, because it might be 1.99, right? And how far off can it be for certain parts of engineering? Well, in some cases, it has to be pretty precise, doesn't it? This is going from what value to what value? Exactly. So negative 2 to 2. Obviously, our graph that's above is this curved one here, which is a negative x squared plus 4. And the graph that's below is this y is equal to 0, right here. So that would be our setup. I didn't put a dx, did I? Why did I put what at the end? Oh, here? Oops. Oh, this shouldn't be there. But this over here? Oh, okay. You were asking about the. Yeah. No, that's me going see now. I was getting thirsty. Not for these. We're just doing a setup. Okay. Now, which one's the blue here? Y2. Because negative before the x squared means it's reflected, flipped upside down, right? So, I mean, if you don't remember that, again, you can graph it and see it and so forth. But I'm assuming negative 2 to 2. If I was real sharp, I could do that in my head. I'm not sharp. That's what it looks like. Okay. Yeah, it is. Okay. Well, it took me a while. So negative 2 to 2. Graph, this one is above, so the negative x squared plus 2. Minus the one is below. So above minus the below, which is the x squared minus x. Dx. Questions on the setup on those? Now this, the integrand of the definite integral is the difference of two functions, which we've already demonstrated in three questions. Sketch a graph of each function and shade a region whose area is represented by the integral. Okay, so 1 to 4. X squared minus 4x minus 2x minus 5 dx. You can do it by hand, or going backwards, this is your y is equal to x squared minus 4x, and this is the y equals 2x minus 5. So if I go to Desmos, so I can find it. Yeah, there it is. Y equals x squared minus 4x. Y equals 2x minus 5. Yeah, it's this area right in here, looks like. Assuming it's going from 1 to 5. One to 4. My eyes off. Oh, so it's not the entire region, is it? So 1 to 4 would be all this in here. So that's what we're trying to find. Questions on? Everybody good with that one? Now, is that correct? Or is there an infinite number of answers? Could I set it up this way? Would that give you the same answer? Negative 4x, negative 2x, negative 6x, negative negative gives us positive 5. Negative. How many ways could I rewrite this? Infinite? I'm surprised the instructions don't say something like sketch shade to read or like sketch a graph of each function or something where it's there's multiple answers. But there are multiple answers. Okay, let's take a look at this one. This one actually wants us to go the entire way to find the answer. So we'll actually do the entire thing here. Yeah, some of you are getting ready to take some classes where they're really challenging on ways of thinking of things. If I gave you a problem, assuming I wasn't in the wrong selection mode. Let's see. What in the world? Oh, I know. Control Z. Sad I teach computers. There. Could you solve that?
Yeah.
What would you do?
Try to isolate the variables.
Let's see. I'm like some kind of genius. Look at this. I'm like Forrest Gump of math, aren't I? It's like, wow, he's like a brainiac.
Not heels, right?
Yeah. Watch me screw it up now that I bragged about myself.
It's like me trying to figure out what they did on Cal Chat.
Yeah. What did I do?
You split the 3 on this side
It
and
might have been.
solve for x.
I mean, you say quotient? Quadratic formula.
Oh, ew.
This is A.
Ew.
This is B. And well, that's C. Yeah. Minus B, plus or minus. There's no genius here. They showed this to us in one of the advanced math classes at WSU. He put that up there and said, I'm going to have you take this home and figure out the answer to it. I probably spent 30 seconds on it before I went and watched Family Guy. But a couple of people in the class actually figured that out because they could think beyond just think, okay, quadratic formula has to be numbers in front of the x squared and in front of the x and so forth. Does it say anywhere that just has to be a number? No. So.
Cool way to think about it. Never good.
Yeah, a lot of the professors really expand your thinking at WSU.
I do here too.
Matthews.
I'm gonna say that.
Well, I got rid of my migraines. It might give you guys migraines. I don't know. Yeah. Now we're not going to eyeball this from now on because we want it to be precise. So again, we have to find our points of intersection. So I'm going to set the x squared equal to 2x plus 8. Get everything over on one side, 0 on the other. Factor that. And we get x is equal to 4 and x is equal to -2. And you kind of eyeball it to see if that looks more or less. My eyes can't go like that, but I think it's 4. That looks right. Now, it says integrate with respect to x and integrate with respect to y. So we'll do the x first. And these have to be x values. So it'll go from x equals -2 to x equals 4. A, yeah. Now what's inside here has to be of the form where you got y equals. Which is good because these are the form y equals, aren't they? So we do the one above minus the one below. Obviously, the straight line is above, isn't it? Which is the 2x plus 8. Minus the one that's below, which is the x squared. And dx. If it's a what? The one that's above. Like, you pick like at a point, and if you draw a straight line from like the one, then the one that's higher in terms of y values is the one that's above. So then this simplifies. We got -x squared plus 2x plus 8 dx. We should get the same answer both ways, so it's kind of a check to see if I screw up, but I can also check that with TI3, TI4. Add 1 to your power, divide by your new power, so I got -1/3 x to the third. Add 1 to your power, divide by your new power, so I got 2 over 2x squared. And if you got a number, you just put an x on it. From -2 to 4.
Why did you change it from x squared minus 2x minus 8 to minus x? Yeah.
Oh, I just rearranged it. So it's in standard form.
So we just multiplied that equation by -1, right?
No, just the 2x plus 8, that's still positive 2x, and that's still positive 8. And this negative just goes with the x squared. I just rearranged terms. No real reason, because when you're plugging in numbers, you're just going to end up with a number anyway. So, okay, so, right. So then we're going to have negative 1/3, 4 to the third power, plus 4 squared, plus 8 times 4, minus, so you plug in the 1 up above here, in for the x, minus, and then we got negative 1/3, not x, what am I doing? Negative 2 to the third power, plus negative 2 squared, plus 8 times negative 2. That gives me negative 64 over 3, plus 16, plus 32, minus negative 2/3 is negative 8 times a negative 1/3 gives us a positive 8/3. And if you see me screw up, be sure to holler. So negative 64/3 plus 48 minus 8/3 minus 12. Negative 64/3 minus 8/3 is negative 72/3, which simplifies to something. And I got 48 plus 12, negative 24 plus 60, 36, I think. We're going to check it with the TA3, TA4 to see if I'm right. Unless you saw a mistake I made. Okay. So I'm going back to my y equals clear 2x plus 8 minus x squared. Then second trace, choose number 7 for the integral. And we're going from negative 2 to 4. So put in negative 2 for the lower. Put in 4 for the upper. That's promising. So we get 36. Okay, so we're going to work the problem again, going to the y's. And we'll see how that goes. Is there any questions on any of that? I don't know where to go back to. Too far. Oh well. Let's see. Y equals x squared. Y equals 2x plus 8. Now we want to integrate with respect to y. The brings in dy. Okay. Instead of looking above minus below, we look right minus left. Now I draw a line here separating the two. How come I did that? Correct. Because it changes, doesn't it? See, like right here, this is my 1 to the right. This is my 1 to the left. It's a straight line. But down here, this is my 1 to the right. Now this curved piece right here is my 1 to the left, isn't it? So that's why you have to separate them into two separate regions. Now, it'd been nice if I'd kept part of it here, but that's okay. I'll do it again. X squared equals 2x plus 8. Take that over there. There's factors. X minus 4, x plus 2. So I get x equals 4 and x equals negative 2. If I plug these in for the y, so I got y is equal to 2x plus 8. And y is equal to 2x plus 8. So for this one, I'm going to have 2 times 4 plus 8, which is 16. This one's pretty obvious. If I plug that in, 2 times negative 2 plus 8, 4. Because remember, our points of intersection are this one and this one. This one is pretty obvious. We could see it was 4, wasn't it? This one I couldn't eyeball very well, but it's obviously 16. And the one that we don't find by the points of intersection, because it's not an intersection of any two graphs, it's just this low point right here. By observation, we can see that's, like you say, 0. Okay, so let's do our setup then. We're going to have two integrals, won't we? And before, I said that this was x equals something. Some of you wondered maybe why I put the x equals there. And then I said this had to be of the form y equals. And that's true for dx. Now for dy, these are now y equals. So you have to put the limits, the integration there of the y equals. What do you think this is of the form? X equals. So that's how we're going to change it, and then dy, of course. That's how we're going to change it to match this. Which means I've already discovered what my y's are, so that part's done. I just have to solve my two equations for y so I can have those in the right form, or the x, so we can have those in the correct form. So we got y is equal to x squared. Square root. Plus or minus square root of y. We'll come back to that. Then the other one was what, 2x plus 8. And I'll solve that for x. So I take that 8 over, divide everything by half. And we'll go 1/2 y minus 4 is equal to 2. X. Go check out a nursing home tomorrow. Maybe I do. I never know. Maybe the doctor just didn't want to break it to me. Yeah. Okay. So if I do this bottom piece right here, what do you think that's comes from? Is that the x equals plus or minus square root of y, or x equals 1/2 y minus 4? This bottom piece right here. Square root of y, 1. Now specifically, this on the left side is which sign? The negative. This one on the right side is our positive. So as we do our setup on that, our area is going to go from, and I'll put it here, but then I'll get rid of it. Y equals 0, what was it, 4? There. And then we had our right side, which was the positive. So square root of y then minus, and then this would be the negative dy. And then y equals 4 to, I think it was 16, wasn't it? Now our right side, right here, comes from the curve again. So what am I going to use? Square root of y, the positive, yeah, exactly. So this will be the square root of y minus, and the left side is the line, which the line, when we solved it for x, yeah. So we'll have 1/2 y minus 4, and then dy. Okay, so it's from 0 to 4. Negative negative becomes positive, so we got 2 y to the 1/2 dy plus 4 to 16 y to the 1/2 minus add 1 to the power, divide by our new power, so 1/4, not 1/6, y squared minus 4y. Wait a minute, I'm not there yet. Thought I was kidding about the nursing home. I think that'd be kind of pleasant to go and be in a nursing home. Not have to do anything all day, just sleep. Yeah, no visitor, nobody to irritate me. No wife to tell me I need to pick up my clothes. Could be the slob. Okay. Make sure I haven't screwed that up. Okay, minus 1/2 plus 4. Okay. So add 1 to our power, divide by our new power. So 1/2 plus 1 is 3/2. So we got 2/3 y to the 3/2. We'll know if I screw it up because we know what our answer should be, right? 36. Add 1 to the power, divide by my new power. We got 2/3 y to the 3/2 minus add 1 to the power, divide by new power, plus 4y. This one, 2 times 2/3 is 4/3. If I plug the 0 will of course go away, but if I plug the 4 in, 4 to the 3/2 power is the square root of 4, which is 2 to the 3rd, which is 8. If I plug in 16 here, so I got 2/3, 16 to the 3/2 minus 1/4, 16 squared plus 4 times 16 minus 2/3 times 4 to the 3/2 minus 1/4. This would be a miracle if I actually get this right. I'm not that good at numbers. This is 32/3 plus 16 to the 3/2 is 4 to the 3rd, which is 64. 4 times 4 is 16, 64 times 2/3, 128. 64 times 2, 128 thirds. Minus 64. Yeah, 64, I think. Plus 4 to 64. Minus 4 to the 3/2 is 2/3, 8, 16/3. 16 minus 4 plus 16. 32 thirds plus 128 thirds minus 16 thirds. Those drop away. Negative or 12, negative 12. 144 thirds minus 12. 4 to 12, 24, 8 plus 12, 36. Ah, fantastic. Was one way easier than the other? Yeah. If you're wondering, well, which way do you do it? You pick the one where you don't have to have two separate intervals. If you can do it all from one value to another value, that's going to always, I think, be your easiest path, mostly. So what? That's good. We'll take a 5-minute break and then we'll start again. So, unless you just want to plow through. I felt bad like all afternoon. Math's healed me. I'm feeling great. I'm ready to go to town tonight. So. Driving up here, I was thinking, oh, I'm going to sleep in the car for 10 minutes, but then I'm worried that my phone won't wake me up, and then students be sitting here wondering where in the world I am as I'm storing in my car. Like I say, math heals. Well, this is my first week really back to work because my computer science course started yesterday. Last week, it's hard. I hate breaks because I'm sitting there staying up to 2 or 3 o'clock at night and sleeping to noon type of deal.
Yeah.
Yeah.
I do the same thing. I don't want to sleep with mom at school. That's perfect. I wake up every day.
Yeah, you get in the habit, but breaks kill me because I screw off so much and then
You gotta keep going with that pattern through the break.
yeah.
That's when you sleep until 11 o'clock.
Yeah.
Yeah, I've been guilty of that, but I try to keep myself.
Yeah, it takes me a couple weeks to get in sync.
Yeah, I'm not gonna remember this until like 2 weeks after my brain's finally contemplated long-term solution.
Did you have it all?
I don't have what I'm good.
Okay. It's in a YouTube video, so if you.
Yeah. I'm good. Type it out on my keyboard. It's not difficult. But that's all. I did it through a long time to this one.
Mm-hmm.
Every single test that I found on this website that I like I found here.
Oh yeah, you're not writing anything down, are you?
I never have. This is actually my first college course in person.
Oh really?
Yeah. First one I sat at the college I'm a junior.
Oh, you are.
Just took online classes. I've been in college for 2 years. 2 years in college. But I've started online. I'm starting since I was supposed to be freshman year and my junior year. And I'm done with my senior year. Right now I'm working on classes for my sophomore year.
Well, see, the in-person classes are really hurting here at Butler. I don't know why. I don't know if everybody's taking it online like you did, but I like it because I can park real close. But if you'd went to Butler 7, 8 years ago, like you were at the high school, if you arrived at the last minute, you'd be out parking somewhere behind the middle school, hopefully, or some bizarre place, and really hoofing it to get to class. There's so many people taking in-person classes.
Yeah, I've never been actual building because I've never stepped foot on any campus I got in here, I got here like 30 minutes early. It was easy to find a class.
It's always good to arrive early to the first class, though this was kind of bad because there was class before us in here. But
Oh, that's not here.
oh, did you?
Yeah.
Yeah, I took a college geometry class at WSU twice because I got a D in it the first time. Full class, and I arrived about the last minute, and I was sitting right in the middle of the class. And he taught the entire class drawing these geometric shapes standing in front of it. Only thing I ever saw the entire class was his back. And I never could see around him. There's no place to move to, and so forth. And it's amazing you don't do well in geometry if you can't actually see what's being drawn. Yeah, and he wasn't the type you suggested that he move to the side so you could see. And so when I retook it, I arrived 30, 45 minutes. I don't even remember how much it was. I arrived way early. And I'm sitting there. I had staked out. I knew where I'd be able to see. And sure enough, he did the same thing that semester. He taught the entire course standing in front of it. But now I was seated to the side, so I could see everything. I did real well in geometry when I could see the board. So.
All that building they're doing with 17, not over it. Is that all taxpayer money or private? I mean, you got a high place that caps in there. It's just like,
Both.
yeah.
Yeah, it's a joint effort as I understand it.
What is that place that's called high place? Is that just a hotel that everybody
I don't know.
yeah,
I haven't been up there in a while.
it's last year. The thing that now shows that apps, I thought that was a new school. That moved back in and put the schools, that bigger school that's now just a. Of course, the money they're spending.
Yeah. It is wild how much you're spending.
Basically, the pricing is like, yeah, the hardest classes are your sophomore, freshman year. They have like, I think it's like there's only one of them that's been and it's not like that. It's not offers an entry to class. Not one. That's like not the one you want to take. That's the one that transfers.
You know how to look up what transfers?
I know how to go to the WSU website and look for it.
Yeah. Yeah, if you type Wichita State course equivalency, every college does this because they don't want you to call. They want you to look it up. You know, they'd rather that than receive 10,000 phone calls. So they got a database out here. So go to Wichita State. Watch this class not transfer. Everybody leaves.
This one does.
Yeah.
So you say Calc 3 doesn't transfer?
It won't. And you need to look at your major too. It might for one of them.
I know I need Calc 3, but the advisor said it'll transfer last
Yeah.
when I was enrolling.
Put Kansas in here, Butler County. and I'll put in math, and we'll see how it transfers.
Let me, I can forward you an email from my advisor.
Calc 1 transfers as math 242. Calc 2 transfers as 243. Now, by the way, these 2000 you see right here, that's WSU's nice way of saying it doesn't transfer. There is no math 2000 course. Applied statistics. See, applied statistics. If you're taking that here, boy, that's weird. That used to transfer. Oh, okay, they did reevaluate it, didn't they? Yeah, I was gonna say it because that's something we agreed upon at the core outcomes meeting. Where's Calc 3? But that's assuming, yes, nothing below.
I've got something that says otherwise, and I can send it to you.
Now that's assuming Math 344 is what they want in their program.
That might be the deal. Because what I was looking at for my major, whatever was offered here, is not going to transfer over, and my advisor told me that as well.
Now you notice this right here, Math 350, and it looks like differential equations transfers, doesn't it? Wichita State had, and we were going to change statistics at one of our core outcomes. I went to that meeting, and they were talking about cutting this and this out of statistics, and they're asking everybody if they were okay with it. They said, K-State, are you okay with it? Yeah, we're fine with it. KU, are you fine? Yeah, we're fine with it. We went to Wichita State, and Wichita State, they just acted really funny when it came to them. And they said, well, we have a course that will transfer into. And the way they said it, they started then asking questions. Well, is this a course that's on degree plans? And said, no, it's not on a degree plan yet. So WSU creates a dummy course that things will transfer into. I would be shocked if this is on any degree plan at with WSU. It used to transfer in as a 500 class. I was taking differential equations as a review class when WSU came down and said we're not taking this as 500 anymore. In mass, half the class left after that night because otherwise they're just taking it for fun. And I was just taking it for review, so I stayed in there. Anyway, this is how you can go. Don't believe what anybody tells you. This is their official database from WSU where they say this is what transfers.
I've got a PDF from that specifically Butler Community College Engineering transfer equivalency. And if you guys want that, I can send it to you. It shows you what's excluded depending on your major. It does, yeah, that's exactly what it is.
Their engineering is different. Like they don't take there's different ones with it. But math degree does. So they'll take like one of the math courses. I don't remember what it is. Maybe it is Calc 3. I don't know. But yeah, if you're taking computer science courses from Butler, about none of them transfer. You see a lot of 2000s here. Yeah, they're and that's true with my classes too. They're not picking on Butler. Most of my Cali classes, computer science courses, they don't take. They just I doubt it. They used to. We offered it at Cali, they offered it here, but again, WSU said, hey, we're not taking it, which makes sense because it's actually, I think, a 500 level class at WSU, and 500 levels junior level, and you can't take a junior level class and transfer when 2 year colleges are supposed to be with freshmen and sophomore.
How did you say you took from college algebra?
Well, a lot of linear algebra is college algebra. So when I took it at WSU, 80% of the class I knew already. There was just a portion of it I didn't know. So.
Well, if you wanted to learn linear algebra at Butler, you should take college algebra.
If you've forgotten it all, yeah. Yeah, if you have to take that class, they're assuming you've covered all that Gaussian elimination and backward substitution and inverses, matrices, and all that. Determinants. Okay.
But you're good for top one, top two, top four, and top.
I know that I know that for like a computer science major here in Butler, they were moving out 3 of the foreign division for the associate's degree. I'm assuming that may be why.
Interesting. They haven't canceled. They haven't. They're still taking ours from Cali, but we don't do ours different at Cali.
I freaking hate physics. I work in a bunch of physicists.
Now I'm not going to do a lot of these by hand. I'm just going to do the setup because I think I've shown you enough by hand. Hopefully you remember it now. Now we're going to graph this to see what we're dealing with. Because the instructions are to sketch the region bounded by the graph and find the area of the region. So y equals x squared minus 3. Y equals negative 3x plus 1. X equals negative 2. X equals 0. Let me copy that. Okay, so x equals negative 2 is right here. To x equals 0, which is right here. And we're finding this area in here. This is one that I could see myself putting on a test, because you should be able to graph this easy, right? You know, x squared minus 3, that's your parabola shifted down 3 units. And you should be able to graph a line. Okay, so our setup, we want to find the area. I'll go from what value to what value? Negative 2 to 0. And what goes first? The line, so negative 3x plus 1, because the red is above. And then minus the one that's below, which is this curve here, which is our square minus 3. And then dx. Oh, in the first test. Well, I'm not saying it will be. I'm just saying this is a possible one. I wouldn't give you something that you couldn't easily just look at and graph. So, you know, like x squared minus x plus 7 or something like that. Okay, so we got negative 3x plus 1. And then you can simplify it if you want. If you just want to put parentheses there, that's fine too. Calculator doesn't care whether you simplify or not. Then I'll do my second trace. Choose number 7. And it's from negative 2 to 0. So negative 2, inner, 0, inner. And I'll take it there. Everybody good with that? I won't ask you to do a whole bunch of by hand, because what kind of math was I doing when I was doing that? Probably even before that. That was like pre-algebra, right? Adding fractions, subtracting fractions, adding integers, and so forth. Yeah, I'm not going to sit there. That's a bunch of busy work if we do all of it that way. Questions on that one? Mhm. Right. Like this part right here is what I'd expect them to work on that. Make sure you know how to do nothing by hand. So if I ask you to do it on test, you can do it by hand. Because I will ask you to do some of them by hand on the test. But other than that, then you can do the setup, plug in your calculator. I'm fine with that. Okay, let's take a look at this one. Got f of x equals x squared plus 8x, and g of x is equal to 0. Let's see, if I find the points of intersection, because it doesn't give me those here in this problem, does it? So I'll set the x squared plus 8x equal to 0. Factor out an x, gives us x plus 8. So we got x is equal to 0, and x is equal to negative 8. So we'll go negative 8 to 0. This is 0 here. Now, if I were to plug in negative 1 here, negative 1 squared is 1, right? And that's 8 times negative 1 is negative 8, so I get a negative 7. So where does that tell me where my graph is? I think somebody said down, but I'm not sure if they meant pointing down. It's probably up like this, isn't it? Yeah. Because it's a positive x squared, so I know it's going to open up. And if I did 1 point, and that 1 point is down here, there's no choice. It has to go like that. Which tells me right away which one's above and below, right? Because the 0 is right there. So this is the one that's above. This is the one that's below. So I'm going to have 0 minus, and then the x squared plus 8x. So y equals 0 minus, why'd I put a 0 there? X squared plus 8x. Second, oops, let's try that again. Second trace, which is number 7, negative 8 to 0. So our answer would be 85.33. One thing, if you've never used this function, if I did second trace, it shows number 7. Lower limit, let me put in negative 12. And then I'll put in 0. Error invalid. How come? Yeah, the intersect points aren't on our display. Many of these functions that are underneath the trace, if you've used them, whatever you put in there has to be on your display. So you have to zoom out in order to do that if you want to do negative 12. So anyway, I don't know if you have any like that, but if you do, that's what you have to do. If you've never zoomed out, you press your zoom and you choose the third one, zoom out. Doesn't look like it does anything. You press enter one time, zooms out by a factor. Each time you press enter, it zooms out one more time. If you press enter too fast, it goes to Never Never Land, will never come back. See the 4 little dots there? Yeah. It's not loading. It's an infinite loop. You have to press enter to get it to come out of it. And then zoom 6 puts you back to your standard view. Hopefully. No? Because this is 0 minus, and a negative out in front reflects it. Yeah, it's a shame they don't cover the TA3, TA4 more in college algebra. Oh. Okay, so let's take a look at this one. Y is equal to x plus 1. Y is equal to 5 minus x. Y is equal to 1. Desmos is ruining me. I'm becoming really lazy. I love Desmos. So y equals x plus 1. Y equals 5 minus x. And y is equal to 1. Would just be two integrals.
I see two times.
Yeah, actually, you could use geometry to do it. We're going to use calculus. The what? It would in this case, but yeah, because area equals 1/2 times base times height. As long as you showed work, I'd be happy. Unless I specified to use calculus. Yeah, if I don't specify, I don't penalize you because I'm too feeble-minded to actually put in instructions for what to do. It's fair game then. Paste. I heard 2 integrals, and you can do it that way. And maybe I'll just do it that way. Could I do 1 integral?
Yeah.
I could, because if I look at it in terms of the y's, whatever that would be, 3. So this is 1 to 3. And this is my graph on the right side, minus this is my graph on the left side. So that would work, wouldn't it? Any preference which way you want to see it? The one integral? Okay, we'll do it this way then. Now, remember when we set it up this way with respect to y, these, instead of being x equals, have to be y equals. And this has to be the form x equals. We're specifically going to do above or right minus left. So right minus left. Now they do have to be solved for x, so I'll do that first. This one right here, if I take the 1 over, I get this. Take let's see, take that over there, take this over there, I get x equals 5 minus y. I guess that's black, isn't it? I shouldn't have to look this up. That's really lazy. Okay, y equals x plus 1 is purple. So this is purple. And this one must be our black. Okay, so we're going to have from 1 to 3. Then one on our right, which is the black, which is 5 minus y. Minus the one on the left, which is our purple, which is y minus 1. Does everybody see the setup on that? The big part on this is you have to keep in track when you're doing respect to y. These have to be y equals here. And we looked at where this went from y equals 1 to y equals 3. And then whatever functions you put here have to be in the form x equals. Specifically, the one on the right minus the one on the left. So if I graph that, or not graph it, you would, find points of intersection. There's actually 3 points of intersection here. This is where you set the purple equal to the red. This is red. So, and this is where you set the purple equal to the black. Black equal to red. Okay, let's see, what do I got? I got 5 minus y. You can put any variable. Minus y minus 1 or x minus 1. Okay, that looks right. Now do second. Trace. Choose 7. 1 to 3. 4. Which, like I say, 1/2 times base, which is a distance of 4, times height, which was 2. 4 times 2 is 8. Yeah, gives you the same thing. Questions on that one? Okay. I'm going to skip this one because they're kind of all the same because I want to show you trig. The last 2 are trig, so I'll make sure I get these covered. So let's take a look at this one. Time's slipping away fast. Time flies when you have fun. Y equals 2 plus sine x. Y is equal to 3 minus sine x. Okay, so we'll graph this. Obviously, these are our limits of integration, but we're going to graph this, see which one's above and which one's below. So y equals 2 plus sine x. And y is equal to 3 minus sine x. And what's pi? Pi is like 3, right? So 3/6, that's 5 times 3 is 15, divided by 6. Oh, boy, that's a harder one. 2.5? Okay. So 1/2, it's approximately about right here. It looks like that point right there, right? 2.5 looks like that. Okay, so that kind of makes sense there, doesn't it? Now, if my point, if this had been like 11 pi over 6, what we'd have is we'd have 2 separate integrals. Where this one would be above, yeah, because it switches. Now this is below. So I was pretty sure this was the case. To show you how you determine that, you can still do your points of intersection with this. So 2 plus sine x equals 3 minus sine x. Get all the signs on one side. So sine x plus sine x equals 3 minus 2. We get, boy, that's the exact one I did in the review. And we already said from the unit circle where sine is equal to 1/2 is the pi over 6. and the 5 pi over 6. So that confirms that even though they give this to us, those are actually our points of intersection, and one is definitely above the other one, the entire way. So, let's see. Oh, it's sloppier as I get older. Right, if I had something like that. Yeah. I don't think I usually put something that hard on the test. If I put trig on the test, I don't make it so you have to graph it. The reason why is because they made it such that now I may give you the actual integral to find, but they made the TA3, TA4 optional, so I can't really, unless I allowed you to use your phones and so forth, then might as well just see all the answers from that way, right? Use your phone?
She said you could use
Oh, I wouldn't.
on your phone or your laptop.
Shoot, if he gave me my phone, I would have got an A on every test. Is this instructor like 80 years old, hadn't heard the math way? And okay, my blue, which is, let's see, this one, 2 plus sine x. This is blue. And this one is my green. Okay, so my blue is above. So I'm going to have 2 plus sine x minus 3 minus sine x dx. I took a class, a graduate class at WSU where he allowed us to use our TA3, TA4s if we wanted to. And he had a lot of definitions on there. One guy's bragging before the test how he put every definition into, you can download Notepad for your TA3, TA4 if you didn't know. But he had downloaded that and he had every definition in there and he was bragging about it. And we're all looking at me, it's like, oh, just go die, you know. And one girl in class, she was raising her hand, and the professor is Professor Richardson. He's been like there forever. He might still be there, I don't know. But she said, "You're not going to let us use a calculator on test, are you, the TA3, TA4? And she was saying that because of that guy bragging. And he said, "Oh, I don't care, go ahead and use it." And he did very well. We weren't very happy with him. We had to memorize all the definitions. Yeah. Say, hey, buddy, I think I need $20 to forget what I heard before class. Okay, that's why I do open note, by the way, because if you're clever with TA3, TA4, you can download Notepad. You can put every formula from this course into your calculator. I guarantee it's much easier to write on that piece of paper than it is putting your calculator. Okay. 2 minus 3 is -1. Sine minus, that gives me 2 sine dx. So that gives me, let's see, negative x. What's that give me? Integral of sine. Cos negative, yeah. So minus 2 cosine x. Pi over 6 to 5 pi over 6. Okay, so then I plug in the values. I'm going to have negative 5 pi over 6 minus 2 cosine 5 pi over 6 minus negative pi over 6 minus 2 cosine pi over 6. Considering that sine of pi over 6 is 1/2, and considering where these are located, keep that in mind. What is cosine of 5 pi over 6? The square root of 3 over 2 is correct. Negative. 5 pi over 6 is over in quadrant 2, and the x's are negative there. Okay. How about cosine of pi over 6? Positive square root of 3 over 2. Okay, so negative 5 pi over 6 plus, those 2's cancel, we'll get square root of 3. I'll go ahead and carry that sign through. Plus pi over 6, 2's cancel, minus square root of 3. Negative 4 pi over 6, 2 pi over 3. Why do I have a negative? Did I screw up?
Maybe close this through. Since you're carrying the sign through, like it change that negative and then to positive.
I would. Good eye. Okay, so 2 square root of 3. Multiply top and bottom, or actually I can just do the mixed number rule. That's 6 square root of 3 minus 2 pi over 3. It's only good if you end up with what sign? Positive. You're finding area, you can't have negative for what we're doing. Let's see. So 6 square root of 3 minus 2 pi. That's good. Positive. Now, assuming I didn't make a basic math mistake besides that one you found, that'd be our answer. So, questions on that? Okay. Let's take a look at the last one here. And I may use the identities because I can use identities to find the integral of this. F of x equals cotangent x, and g of x is equal to 1. From pi over 4 to 3 over pi over 4. Okay, we want to find the intersection of these, so I can set them equal to each other. You can. There's another way of thinking about it. Cotangent, we said, is x over y. For it to equal a positive 1, that means these have to be the same, right? Yeah, so where are they the same at? Pi over 4, because they're both square root of 2 over 2. So square root of 2 over 2 over square root of 2 over 2 is 1. And one other place.
It'd be the negative 3 pi. It'd be the negative
5 pi over 4. Which doesn't match this, but that isn't necessarily bad. Assuming I wrote that down right. I'm sure that's 3 pi over 4. There it is. Okay. Because 5 pi over 4, it's negative square root of 2 over 2, negative square root of 2 over 2 over negative square root of 2 over 2, which gives you a positive 1 again. Now, we're not going through the entire intersection here, but that's fine. We just need to now verify the above and below, right? Do I even really need to worry about two integrals? No, because this is less than this, isn't it? And this is where it changes. So we're fine in that regard. And then C. Equals cotangent x, and y equals 1. And we're looking from pi over 4. You can actually limit the x values down, but I have trouble with that, seeing it sometimes. Pi. Where in the world's pi? Functions?
next to 0.
Pi over 4 and 5 pi or 3 pi over 4. Can you? Sure enough. Yeah, that I've used, but I don't do a lot of trig. Okay, so red, blue, okay. Control, well, actually I don't need to. Obviously, where they're intersecting is right here and so forth, and this is where we're finding. So we are going from the x value they give us to this x value, where this one's above and this one's below. So the straight line is our what? 1. So the y equals 1. So pi over 4 to 3 pi over 4. So we'll have 1 minus, and cotangent is now this curve down here, the purple, dx. Okay, so I'll split this up in 2 separate integrals. This is good. We're going to review this later on, except for there should be a minus here. Cotangent, in terms of our properties, not the x and y, but in terms of sine and cosine, is what? Cosine over sine. This one, the integral of 1 is x, from pi over 4 to 3 pi over 4. Now here, I'm going to do a u substitution. Because I don't remember what cotangent is, and I think a lot of you may not remember too. Some of you may. What is the integral of cotangent? Anybody remember? Okay. What would our u be? Sine x? Because remember, if you got a fraction, you try to let u equal to the denominator. Yeah. Okay. So then the derivative of sine is cosine, and we add on our dx, which works out perfect because it has cosine x and dx. So this becomes minus, and I'm going to put x's here just to really emphasize there's still x's. And this becomes what? 1 over u du. This is why I did that recall, because these are items you need for the problems I was going to show. Okay, so that's 3 pi over 4 minus pi over 4 minus the integral of 1 over u is almost natural log of the absolute value of u. This is still x's. But now we're going to plug our u back in. U is sine x. What's that? 2 pi over 4, or pi over half, minus natural log of the absolute value of sine x from pi over 4 to 3 pi over 4. So pi over 2 minus natural log of the absolute value of sine of 3 pi over 4 minus natural log of the absolute value of sine of pi over 4. What's sine of 3 pi over 4? Yeah. So square root of 2 over 2. How about sine of pi over 4? 2 over 2, which means that cancels, and our answer is pi over 2. Questions on any of that? Okay, I'll let you finish writing that down, then I'll give you some problems I outlined. If this isn't enough problems, do more. your purpose is to master the material so you can do well on the test, right? So if this isn't enough, then do extra. It's great as I get it. Oh, really, it's a completion type thing. When I say odd ones and the odd ones are worked out in Calc Chat, then if you're not getting 100 on those, then I don't know what to say at that point. If any of these you cannot figure out, you can always email me and say, hey, I can't figure out number 19. I looked at Calc Chat. Can you work it? I'll work it in the YouTube video format and send it back to you. So definitely use that if you need extra help. And not even these, but if you have other ones besides word problems, in the section that you want to see work, just email me and I'll work them and send them back to you. Because again, I check my email every day. So.
I can't remember, with Calc Chat, you don't need your same personal numbers.
Yeah, it's just right.
And then you can also use CalcView.
You know, I don't think I've ever been to CalcView.
CalcView, yeah, they have like a professor, they do it on like a clear window or whatever. They talk about it. But it's only certain highlighted ones in the book.
Interesting. Oh, is that what those the highlighting is? Okay. What is wrong with this silly thing? Home. Of course, it probably helps if I actually click it. I'm blind. Okay, assignment, new assignment, section 7.1, indent by 3, add item. Edit. Page 400. That's not right. Yeah, 450, I guess. Page 450, numbers 5, 7, 15, 19, 21, 23, 27, 37, 39, 41. You can pull us up on Canvas. How many problems is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. So I'll make that 20 points. Let's see. Online file upload, so you can scan it and turn it in. Now, don't upload weird things like pages from your MacBook. I can't read pages. PDF, a Word document. There's a nice app called Cam Scanner that you can take pictures of your paperwork and they can upload it. Oh, yeah. You can also just turn it into me, and that's perfectly fine. Like that. That's my. That's one of my Australian shepherds. That's not the one that had the seizure. What? No. She the or older ones when it's seizure. So, but yeah, they're a delight.
I just wanted to introduce myself.
Okay. There you go. Normally I wouldn't mind.